Welcome back to physics short classes. In this video lecture, we are going to discuss about dielectrics and polarization, where we are going to discuss the meaning of dielectrics and types of the dielectrics, and also how they get polarized in the presence of the external electric field. What are dielectrics? Dielectrics are non-conducting substances. They have no or negligible number of charge carriers. Hence, they do not take part in conduction of charges. There are two types of dielectrics. The first one is non-polar dielectrics. The molecules of the dielectric with the centers of positive and negative charges coinciding with each other is known as non-polar dielectrics. Hence, they do not possess permanent dipole moment. Examples are molecules of oxygen and hydrogen. The other type is polar dielectrics. In case of polar dielectrics, the molecules with centers of positive and negative charges are separated. Hence, they possess permanent dipole moment. The examples are hydrochloric acid and water. Now let us see how net dipole moment is developed by dielectric. First, when we consider non-polar molecules, we can see that the centers of positive and negative charges of each molecule is exactly coinciding with each other. So therefore, without external electric field, each molecule and hence the entire substance do not possess net dipole moment. Whereas when there is an external field, then the centers of positive and negative charges are pulled apart, as we can see in the picture. Therefore, each molecule and hence the entire dielectric substance develops net dipole moment. But when we consider polar molecules, we know that each of the molecule have dipole moments. But we can see that due to the thermal energy, the orientation of the dipole moment of different molecules are random, and hence the dipole moment of the molecules cancels each other, and hence the total dipole moment of the entire substance will be always zero without external electric field. But when we applied external electric field, we can see that the molecules will start to align themselves in the direction of the applied field, and hence it will start to develop a net dipole moment. What are the differences between them? Let us consider one by one. For polar molecules, the molecules have permanent dipole moments, whereas for non-polar molecules, the molecules do not have permanent dipole moments. Dielectrics develop net dipole moment due to the alignment of the individual dipole moments in case of the polar molecules, whereas for non-polar molecules, dielectrics develop net dipole moment due to induced dipole moments. That means due to the separation of centers of charges. In case of polar molecules, polarization depends inversely on thermal energy. As the temperature is increased, the orientation or the alignment of the dipoles will be disrupted, which decreases the polarization. Whereas in case of non-polar molecules, polarization is nearly independent of the temperature. What is polarization? A dielectric develops a net dipole moment in the presence of an external field, either due to the alignment of the dipoles or due to the induced dipole moments. Dipole moment per unit volume is called polarization. For a linear isotropic dielectric, P is equal to chi E into E, where chi E is known as electric susceptibility of the dielectric medium. Now, what is linear isotropic dielectric? Induced dipole moment is in the direction of the field and proportional to the field strength. Such dielectric is known as isotropic dielectric. For our convenience, throughout our study, we are going to discuss about linear isotropic dielectrics only. The polarized dielectric is equivalent to two charged surfaces with induced surface charge densities sigma p and minus sigma p. Here we can see that due to the alignment or the stretching of the molecules, there will be charges are developed at the surface. The field produced by these surface charges oppose the external field, thereby the total field in the dielectric is reduced. Let us see how. Look at the diagram. So due to the alignment or the induced dipole moment, the centers of positive and negative charges of neighboring molecules which are lying well inside the dielectrics, they will be brought closer to each other. So as we can see that the positive charge of the one molecule is brought closer to the negative charge of the other molecule. They will get neutralized. Similarly, it continues throughout the dielectric medium. But we can see that there are some unneutralized charges of opposite kind present at opposite ends of the dielectric, which is known as the induced field here. They will create the induced field. A uniformly polarized dielectric amounts to induced surface charge density, but there is no volume charge density. There is no charges. Unneutralized charges are not present inside the dielectric, hence no volume charge density. Due to the polarization, unneutralized charges of opposite kind are formed at opposite ends of the dielectric. The field produced by these surface charges opposes the external field. Hence, the total field inside the dielectric is reduced. Thank you for watching the video.